Hi everyone. In this lecture, we will study from a sequential circuit point of view what is a state of sequential circuit, what is a state table, what is a state diagram, what is next state equation, what is output equation. Okay. So basically, we already know what is a sequential circuit, what is a combination circuit. Okay. In a sequential circuit, you know that. Okay. So let us see. So you know in a combination circuit, what happens if you have a combinational circuit? So in combination circuit, the output, if you notice, the output is basically that is a function of a current input. Okay, so I can say that this output is a function of current input, or I can say output is basically function of input. Okay, but in a sequential circuit, what happens? In a sequential circuit, you can notice that output is basically function of current input, I can say. So the okay, so the output, the next output, I can say the output will depend. Okay, the next output, I can say the next output, that will depend on the current input and also on the current state. Okay, so current state. So you can notice this is the definition of combination circuit and sequential circuit. We already know. Okay. So now let us see what is state of a what we mean by state of a circuit. What we mean. Okay. What is a state table? What is a state diagram? What is the next state equation? So these topics we need to study. Okay. So let's start. First, let's see the first thing. What is that? What is output of flip flop? Okay, so you know that if you have a flip flop, for example, let us assume you have this D flip flop. In this D flip flop, we know there are two outputs. Okay, so there is Q and Q bar. Okay, so and let us assume this D flip flop is positive as triggered. So this is your clock. Okay, and this is your D input, and these are outputs. This is Q. This is Q bar. Okay, if this Q is 0, then this Q bar will be 1, and if this Q is 1, then this Q bar will be 0. Okay, now what if I say that output of flip flop, then so do I mean Q or Q bar? So this is the point. Okay, if I directly say, for example, let us assume that here you have 1, here you have 0. Okay, because if this Q is 1, then Q bar will be 0. Now for this, what will I say when I say output of this flip flop? Okay, output of this flip flop. Should I say 1 or should I say 0? Okay, because you can notice in a flip flop we have two outputs. This is Q and this is Q bar. These two outputs we have. Okay, so I'm asking what is output of this flip flop? Okay, so the answer will be here 1, not 0, because remember, when we say output of flip flop, then basically we want to say the Q output, not the Q bar. Okay, so remember, output of flip flop, basically that means Q out. Okay, and that means 1. So for this flip flop, I can say the output is 1. Okay, and because the output is 1, so I can say that in this flip flop we are storing 1. So remember, this flip flop stores 1. Okay, so in this flip flop, because the output is 1. Okay, and I told you, by when we say output of flip flop, then basically we want to say the Q output, not the Q bar. Okay, so the output of this flip flop is 1, and because the output of this flip flop is 1, so I can say that in this flip flop the bit that is stored, because every flip flop will store one bit. Okay, so I can say in this flip flop we are storing this bit. Okay, so this 1 is stored. Okay, so this is what we mean by something is stored in the flip flop. Okay, so this is also called state of this flip flop. So you can notice, okay, all these three things are same. Let me tell you, for this flip flop, okay, from this flip flop point of view, what I can say, I can say that, okay, for a flip flop, I can say, if you have a flip flop, then all these three things are same. Okay, what is the output of this flip flop? Okay, output of this flip flop, that is your Q output. Okay, you know, output of this flip flop is your Q output, and that is same as, I can say, what is the bit stored. Okay, so that is same as bit stored in this flip flop. Okay, in this flip flop, and that is same as state of this flip flop, state of this flip flop. Okay, so remember, in if I tell you what is the data stored in this flip flop, which bit you are storing, so in this flip flop right now this 1 is stored. Okay, and similarly I can say that what is the output of this flip flop, that is 1. Similarly I can say what is the state of this flip flop, that is also 1. So output of this flip flop is basically same as state of this flip flop. So state of this flip flop is basically Q equal, that is 1. Okay, so this is the state of this flip flop. Okay, so you can notice here, state of flip flop, that is simply the bit stored in this. Okay, and that is simply the flip flop output. So all these three things are same. A state of a flip flop, that is same as the bit stored in it, and that is same as flip flop output. All these three things are same. Similarly, if you have a sequence circuit, for example, register is a sequence circuit. In register, what we have multiple In register we have basically if you have n bit register, then we have n flip flop. So let us assume this is your register. Okay, so let us assume that you have 3-bit register, so it means we have 3 flip flop. Okay, these can be like they can be jk flip flop, d flip flop, t flip flop, they can be any flip flop, sr flip flop. Okay, so let us assume these are d flip flop. Okay, now this is your register. In a register you already know that in the register all the flip flop they share the common clock pulse. Okay, so this is your clock and this is your register. This is the 3-bit register. Okay, and let us assume that this register is like this. For example, okay, I can say that okay, this register is, let us assume this register is parallel in and okay, so this is parallel in parallel out register. So let's assume the register is parallel in parallel out. So you can notice this is your parallel in parallel out register. I can say the data, if you want to store the data you can apply the data in parallel, and if you want to read the data then you can read the data in parallel. Okay, so you can read the data also in parallel, you can read. Okay, so anyway, now you can notice that let us assume that this is 1, this is 0, and this is 0. Then in that case what is the state of this? This is your register, and register is a sequencer circuit, so this is your sequencer circuit. And okay, now you can notice if this is 1, this is 0, this is 0 at any point of time. Let us assume at time t equal to 0, this is the situation. Okay, this is the situation at time t equal to 0. Okay, so now you can notice, let us assume that okay, at time t equal to 0, you are applying here. Okay, here 0 and here 1, this is what you are applying. So this is the situation at time t equal to 0. Okay, so let me tell you. Okay, at okay, at this time, for example, there is a clock, you can notice. Okay, there is a clock, and let us assume that at this point, okay, this let us assume at this okay, this is your time t equal to 0. Okay, so let's assume at this time. Okay, at this time this is the situation at this time. Okay, so at this time this is the situation. Now you can notice one thing, that these flip flop, okay, we have 3 flip flop, 3d flip flop we have, and these you can notice these are positive edge triggered flip flop. What it means? It means that when clock is going from low to high, okay, then these flip flop will basically do their operation. Okay, so now you can notice at this point of time, at this point of time, this is the situation. What is the situation? The state of this flip the state of this register, the state of this sequence circuit, what is that? Okay, that is nothing but 100. Remember, state of sequencer circuit, what is that? State of a sequencer circuit, that is nothing but the flip flop output combination. Okay, because what is a sequencer circuit? Sequencer circuit is a sequence is a circuit with flip flop. So you can notice this is a sequencer circuit. Okay, this is a sequencer circuit, and also this is also a sequencer circuit. Okay, so you can notice that in a sequencer circuit, what is the state? State of sequencer circuit is basically, okay, the flip flop output combination. Okay, so here you can notice at this point of time. Okay, at this point of time, okay, you can notice that in this we have 3 flip flop, and what is their output combination? The output combination is 100. So this is the state of this sequencer circuit. So at this point of time, I can say what I can say. I can say state of this circuit, state of this register, or I can say state of this sequencer circuit, that is 100, because that is state means flip flop output combination. So current state of this register, this is your parallel in parallel out register. Okay, and the current state is basically that is the flip flop output combination. So the current state is basically 100. Now what will happen after one clock pulse? Okay, what I mean by one, after one clock pulse, after one clock pulse means okay, because all these flip flop, these are positive edge triggered, so I want to say what will happen after rising edge. Okay, so basically at this point what will happen? Okay, so this is what I want to find out. Okay, so what we want to find out, we want to find out at this point what will happen. Okay, means after one clock pulse. Okay, here what will happen? So you can notice that right now, you can notice here. Okay, when you are here at this time, you can notice the state of this sequencer circuit is 100, because the state of a circuit means that is the output combination. So I can say the flip flop output combination, that is 100. So this is the current state of this circuit. Okay, now after one rising edge, because all these flip flop, these are positive edge triggered, so I can say that after one rising edge, or I can say after one clock. So after one clock means at this point of time, at this point of time, what will be the situation? Okay, so at this point of time, what will be the situation? Let us write it. Okay, so okay, now at this point of time, let me write the situation at this time. Okay, at this time, at this time. Okay, so you can notice one thing. Okay, right now, okay, when you are here at this time, the state of this circuit is 100, and you are applying this input a equal to 0, b equal to 0, c equal to 1. This input you are applying. Now what will happen after the rising edge? Okay, so this is your rising edge. After this rising edge, after one rising edge, or I can say after one clock, okay, so after one clock, what will happen after one clock? So this will happen that this data will be stored. Okay, I can say this data will be available on the output of d flip flop. Okay, so you can notice at this point of time, means after this rising edge, after this rising edge, what will happen? This data that you are applying, okay, this data that we are applying, this data will be stored here. So I can say that this data, this new data that you are applying, basically that will be stored here. So now you can notice what is the state of this circuit now at this point of time. At this point of time, the circuit, the state of this circuit is basically 001. Okay, because state of circuit means the output combination, the flip flop output combination. Okay, so this is what we want to say, state of sequential circuit, that means flip flop output combination. And similarly, the state of register, because register is also a sequential circuit, state of register, that is nothing but flip flop output combination, and that is nothing but the register content. For example, okay, this is your register, you can notice this is parallel in, parallel out register. Okay, right now at this point of time, what is the data that is stored in this register? So okay, right now the data, the register content is 100. This is the register content. Register content means the flip flop output combination. Okay, so you can notice at this point of time, this register, this is your 3-bit register. In this 3-bit register, right now the data is 100. This is your register content at this point of time. Okay, so this is the register content. Okay, and you can notice after one clock pulse, what will happen? After one clock pulse, the register content, okay, that has changed, and now the register content is 001. Okay, now this is the register content. Okay, so this is what we want to say. Okay, I hope all these points are clear to everyone. So you can notice that in a flip flop, or register or sequencer circuit, basically in any flip flop, or I can say in any sequencer circuit or in any register, okay, what is the stored data? Okay, what is the data that is stored? For example, in this sequencer circuit right now, what is the data that we are storing? So right now the data that is stored, that is 100, means the data that is stored is basically the flip flop output combination. So you can notice, okay, so the stored data is available on the output of flip flop, or I can say register, and the output of the flip flop or register, that is basically, that is called the data that is stored in register. Okay, I hope all these points are clear to everyone. Okay, now let us see. For example, here you can notice this is a flip flop. This is a D flip flop, which is positive edge triggered. This is the symbol for positive edge triggered flip flop. So this flip flop is basically positive edge triggered. Okay. Now you can notice that, okay, positive edge triggered, what it means? It means that when clock is going from high, low to high, when, okay, when this clock is going from 0 to 1, then what will happen? This data that you are applying, okay, this input data, that will be stored. So you can notice this input that you are applying, that will be stored in this flip flop. And okay, storing data in this flip flop, what it means? It means it will appear on the output. So remember, in a flip flop, okay, the data that you are storing, that is basically the data that is appearing on the output. So remember, storing a bit, that automatically means that, okay, what is the output? Okay, so you can notice this one is stored in this flip flop, and this appears on the output. So basically we say that whatever is the bit that appears on the output, that is said to be stored in this flip flop. Similarly, you can notice here, okay, if you apply this, okay, if you apply the input 0, then what will happen? This 0 will be available on the output. Oh, because 0 is available on the output, so we will say that 0 is stored in this flip flop. Okay, so this flip flop is storing 0. So this is the terminology. Okay, for example, see this. Okay, so what is the current state? If I ask you, okay, this is a register, you can notice this is a shift register, this is a write shift register, this is a serial in, serial out. So you can notice, okay, this we have already seen in the register chapter. So this is a serial in, serial out, write shift register. Okay, so this register we have already seen actually. Okay, how to design this register, what is the behavior of this register, all these things we have already seen in the register chapter. So you can note this is your register. Now tell me, what is the current register content in this register right now? What is the data that is stored? So you can notice, what is the register content? Register content simply means what is the flip flop output combination, and that simply means what the state of this register. Okay, so all these three things are same. So you can notice what is the state of this register. For this register, you can notice these are the flip flop output combination. So flip flop output combination is 1000. This is the flip flop output combination. So this is your state of this register, or I can say this is the register content. So okay, you can notice for this, at this point of time, means I can say at this point of time, the register content is 1000. This is the register content. Okay, so I can say this is your register content. Okay, so you can notice register content simply means what is the data that is appearing on the output of flip flop. So the flip flop output combination, that is called register content, or I can say that is your state of this register. So right now this register is in this state 1000. This is the state. Remember, this is the external input, so don't worry about it, because this is the flip flop output combination. So the flip flop output combination is called the state of this register, or I can say register content. For example, consider this. Okay, at this point of time, okay, at this point of time, okay, so at this point of time, what is the register content? Okay, you can notice very simply. So here the register content is 0100. So you can notice this is a 4-bit register. Okay, you can notice because we have 4 flip flop, so it means this is a 4-bit register, and in this 4-bit register we are basically holding 4-bit data. Okay, so this is the flip flop output combination. So this is the register content. So your register content is 0100. This is the register content. Remember, this is the external input. Okay, but this is the flip flop output combination, and flip flop output combination is called the register state. So this is the state of this register. Okay, at this point of time, now you can notice after one clock pulse what will happen. What do I mean by after one clock pulse? Okay, you can notice all these flip flop, they are positive edge triggered. So what it means? It means that when this rising edge comes, okay, so I can see at this point of time this is the register content. Okay, now I want to say what will happen after one clock pulse, means what will happen after this rising edge. After this rising edge, what will happen? So you can notice very simple that after this means here. Okay, here means I can say after this rising edge what will happen. So after this rising edge, you can notice this one will be stored here, this zero will be stored here, this one will be stored here, this zero will be stored here. Okay, so after this rising edge, what will happen? Okay, the new register content, what that will become? The new register content will become 01. The new register content will become 1010. Okay, so you can notice that after one clock pulse, this is the register content. So you can notice at this point of time, okay, the new register content is basically 1010. This is the new register content. I can say that here the register, here the state of this register is 0100. Okay, and after one clock pulse, means after one rising edge, the register content is, the state of this register is 1010. Okay, so you can notice what is the present state. Present state means basically before clock, and next state means after clock. For example, okay, you can notice this is the clock edge. This is the, because all flip flop are positive edge triggered, so I can say that this is your present state. Okay, at this point of time, at this point of time, this is the state. Okay, at this point of time. Now after one clock pulse, this is your next state. Okay, so you can notice at this point of time, this is the present state, and you can notice after one clock pulse, after one rising edge, this will become the next state. So you can notice if this is your present state, then after one clock pulse, the next state will be this. Okay, so this is the point you can notice. Okay, so okay, present state means before clock. Okay, or I can say this is the current state, and next state means after clock. Okay, now you can notice, okay, if your flip flops are positive edge triggered, then what I can say, because here we are saying that present state is before clock and next state is after clock. Okay, now if you know, if you have this information, this added information you have, that if all the flip flop are positive edge triggered, then what can I say? I can say that present state is basically before clock rising edge, and next state is basically after clock rising edge. For example, here in this example, you can notice that in this register we have 4 flip flop, and these flip flop are basically positive edge triggered. So what I can say, that if this is your current state, if this state is your current state, then the next state, okay, next state will come when, okay, after one rising edge. So you can notice if this is your current state, if this blue line, this blue line is your current state, then after one clock edge you will get the next state. So you can notice that after one clock pulse, means after one rising edge, after this rising edge, this is your next state. Okay, so this is the point. So if your flip flops are positive edge triggered, then I can say that present state means before clock rising edge, and next state means after clock rising edge. Similarly, if your flip flop are negative edge triggered, then I can say that present state means before clock falling edge, and next state means after clock falling edge. Okay, so these are some terminology that I am discussing. Okay, now let's see the next topic, that is state diagram. What do we mean by state diagram? So you can notice if you have a sequencer circuit, then sequential circuit basically means circuit with flip-flop. Okay, and you can notice what is the output combination of flip-flop. We have seen output combination of these flip-flop is called state of sequential circuit. So you can notice every sequential circuit, okay, if you have a sequential circuit, then it is a combination of a flip-flop, and the output combination of this flip-flop, that is called the state of sequential circuit. Okay, so you can notice your sequential circuit is in some state. Okay, let us assume you are in some state for maybe, okay, this can be some state. Okay, the flip-flop output combination, remember, and what is the flip-flop output? That can be either 0 or 1. Okay, so you can notice, let us assume that you have three flip-flop, and okay, and this is their output combination. Let us assume, okay, let us assume this is their input combination, this is their output combination, because remember, the output of flip-flop can be either 0 or 1. Okay, so you can notice that the state of this sequential circuit, okay, so that can be, if you have three flip-flop, then I can say that this is a state 100. Okay, now from this state, after one clock pulse, where will you go? Okay, what will be the next state basically? Okay, what will be the next state after one clock pulse? After clock pulse. Okay, so after one clock pulse, or I can say after one rising edge, if your flip flop are positive edge triggered, then I can say after one rising edge. If your flip flop are negative edge triggered, then I can say after one falling edge. And if you don't care, okay, if it doesn't matter whether your flip flop are positive edge triggered, negative edge triggered, if it doesn't matter, then you can simply say that after one clock pulse. So you can notice, let us assume this is your sequential circuit state right now. This is the current state. If this is current state, then after one clock pulse, in which state will this circuit go? Okay, this example we have seen, you can notice this is the circuit, this is the current state of this sequential circuit. Now after one rising edge, what will happen? After one rising edge, this is the next state. So this is what we want to say. Basically, you are in some state, your circuit, your sequential circuit is in some state. State means flip-flop output combination. So this is some flip-flop output combination right now. Okay, now after one clock pulse, what will be the flip-flop output combination? Okay, so this type of diagram is called state diagram. So remember, state diagram is basically just a graph representation of a state transition. Okay, so remember, state diagram is just a graph representation of state transition, how one state goes to another. Okay, so this is just a graph representation. Okay, for example, if you have this SR flip flop, then okay, in SR flip flop, can you create the state diagram? So for SR flip flop, we know this is the truth table, or I can say this is the characteristic table. So you can notice in SR flip flop, when S comma R, when both are 0, then that is basically the next state. This means this QN means, this means Q next. Okay, Q next, basically this is your next state. This is the next state. Okay, so you can, next state means next output. I told you, because in a flip flop, state means output. Okay, so you can notice this next state, and in a flip flop, state means output. So I can say this is the next output. Okay, next output basically means that is the next Q value. That is the next Q value, I can say. Okay, so that is the next Q value. Okay, because output means what? Output means the Q output. Okay, so you can notice that if your S comma R, if both the inputs are 0 0, then in that case the next state will be the same as present state. Okay, so if present state is Q, okay, this is your present state. If your present state, this is your present state means basically this is present output, because state means output. Okay, you can notice, so present output. Okay, so this is the present Q value, this is the present Q value. So I can say that if your input S comma R, if they are 0 0, then the next output, the next state of this SR flip flop, that will be the present state. Similarly, you can notice if S comma R, if S is 0, R is 1, then in that case this will be reset, because you can notice R is 1. Okay, so you can notice R is 1, so I can say the next state will be reset. Reset means 0. So you can notice it does not matter what is your present state, the next state will be 0 if you apply these inputs. So remember, if you apply these inputs, then definitely next state will be 0. Next state means after one clock pulse. Okay, so you can notice if this is your state Q, if this is your state Q, okay, at time t equal to 0, let us assume this is your at time t equal to 0, then what do we mean by Q next? Okay, that simply means after one clock pulse. Okay, so next state means after one clock pulse, means I can say if your flip flop is positive edge triggered, then I can say after one rising edge. After one rising edge, I can say. Okay, so I can say that if this is your current state, okay, then after one rising edge, what will be the next state? If this is your current output, then after one clock pulse, after one rising edge, what will be the next output? Okay, so this is the situation. Now you can notice, if your current state, if your current state is something maybe 0 or maybe 1, we don't know. Okay, if your current state is 0 or 1, then you can notice if you apply these inputs as 0 or 1, then the next state will definitely be 0. Similarly, you know that if s is 1, r is 0, then the next state, if you apply these inputs, then next state will definitely be 1. Okay, similarly if you apply these inputs, okay, and these inputs are basically forbidden, you already know. Okay, so these are forbidden inputs in the sr flip flop, so this combination we never apply basically. Okay, remember s comma r, s equal to 1, r equal to 1, this combination is forbidden, means we should never apply this combination, this we already know. Okay, so this is the characteristic table, or you can say this is the truth table of a sr flip flop. Now, from this table, how can you create? Okay, you can notice if you have one SR flip flop, if you have one flip flop, then for one flip flop, how many states you can have? Okay, so you can notice if you have one flip flop, if you have a single flip flop, then only two states are possible, either 0 or 1. Okay, so if you have this flip flop, then only two states possible. A flip flop can be either in state 0, or if flip flop can be in, because what flip flop does? In a flip flop, we store either 0 or 1. Okay, so this flip flop can either store 0 or it can store 1. So I can say the output of this flip flop can be either 0 or it can be 1. So I can say this flip flop can be in two states. Either, okay, one possible state is 0, another possible state is 1. Okay, now let us create the state diagram of SR flip flop. Okay, state diagram means when this state, okay, for example, state diagram means from this state when can you go to this state. Similarly, from this state when can you go to this state. Similarly, from this state when can you go to this state, and from this state when can you go to this state. So this is called state diagram. State diagram means from one state how can you go to another state. Okay, from one state to another state. So this is your state diagram. So for SR flip flop, this is the SR flip flop state diagram. So let's create. Okay, so you can notice that these are the two possible state of SR flip flop. For any flip flop, only two states are possible. Okay, so either 0 or 1. Now, if you are in this state 0, okay, means your flip flop, means your present output is 0. This is your present state. Now, what input should I apply? What input should I apply such that you will again go to 0? So you can notice if your present state is 0, then either you can apply 0 0, because you can notice this is your present state. If you apply 0 0, then again the next state will be same as the present state. Okay, so you can notice if you apply 0 0, then the next state will be same as present state. So I can say that either you can apply 0 0, or you can reset, so you can apply 0 1. Okay, remember here, okay, when I write like this, then it simply means that first one is S and the second one is R. Okay, so remember this first one is S and the second one is R. Okay, now if you, okay, so this is fine. Now from this state how can you go to this state, means from 0 how can you go to 1, then I have to reset, sorry, I have to set from 0. From this state how can I go to this state, so I have to set, so I can say 1 0. Now from 1 how can you go to 1, either you can apply 0 0, because this, if you apply this input combination, okay, then state will not change, and or what you can do, or you can set, so you can apply 1 0. Now if from this state how can you go to this state, if you are in this state 1, if your flip flop output is 1, then how can you make the flip flop output 0? Very simple, the input that you should apply, this is your S, this is your R, this is your Q. Okay, so you can note the input that you should apply, and that is nothing but you should reset, so that means that is 0 1. Okay, so this is your state diagram of, this is the state diagram of SR flip flop, because remember a flip flop, okay, whatever flip flop you take, that can have two state, because the output of flip flop can be either 0 or 1. Flip flop is a 1 bit storage device, so in this flip flop either you can store 0 or you can store 1. Okay, now what is the state diagram? State diagram means how can I go from one state to another. Okay, so you can also, this is the state diagram. What it means, this state diagram is, remember this state diagram, this is just another representation of this state table. So this is called state table, I can say. Okay, so I can say that this is your state table. Okay, this is same information, remember this is same information we have represented using a graph. So this is this diagram. So you can notice this state diagram, and this state table, they give you the same information, they will give you same information, but they are just, the same information is represented in two different ways. Here we are representing using a graph, and here we are representing using a table. Okay, so this is the point. So this is your SR flip flop state diagram, and this is your SR flip flop state table. Okay, now for this SR flip flop, now let us see how can we write the next state out equation. Okay, if you want to write the next state equation, then how can you do that? So now see, SR for the SR flip flop, this is the state table. We already know. Now let's see how to write next state equation. Okay, means basically I want to write the equation of this Qn. Okay, you already know that in a sequential circuit, this next state, this is a function of present state and the present inputs. Okay, so you can notice. Remember, this is your next state. You already know. So this next state, Okay, or I can say this is the next output. Okay, and this is a function of this actually depends on what is your present state. So what is your present state, and also what are your inputs. So what are your inputs. So you can notice that the next state will depend on present state and also on the present inputs. Okay, so because in any sequential circuit this happens, the next state will depend on the current state and also on the inputs. Okay, now here you can very easily write the equation for Qn. So what will be the equation for Qn? That is very simple. Okay, so equation for Qn will be like this: when S is 0, R is 0, then output is Q. So I can say that when S is 0, so that means S bar. When R is 0, that means R bar. Then output is Q. Okay, so you can notice when S is 0, R is 0, that means S bar, R bar. Then the output is Q. Okay, similarly, you can notice when S is 0, R is 1, then output is 0. So I can say when S is 0, R is 1, then the output is 0. So I can just remove it because that will become 0. Okay, so you can notice this will actually become 0. Anyway, you can notice when S is 1, R is 0. I can say when S is 1, R is 0. When S is 1, so S, R is 0, so R bar. So I can say when S is 1, R is 0, then the output is 1. Now you can very easily see that this will actually become 0. Okay, so finally what I will get S bar, R bar, Q, or S, R bar. Okay, so this is your next state equation. Okay, remember, in this SR flip flop we have this forbidden combination. So remember, I am not saying that this is the only equation. I am saying this is one of the correct equation. This is correct equation. So Qn is equal to S bar, R bar, Q, or S, R bar. This is a correct equation. But remember, because this forbidden combination, so this is a don't care combination. S equal to 1, R equal to 1. This combination we will never use. Okay, this combination is forbidden, so this combination we will never use. So actually the output is don't care. Okay, so what we can say, this output we can write at 0 or 1. That is our wish, that is our choice. So we can either keep it 0 or we can keep it 1. Okay, so that is your choice. Anyway, the point is, what I want to say is this is a correct equation. Okay, so this is how you can write the next state equation from the state table. Now if you have the state diagram, okay, if you have the state diagram, from the state diagram how can you write the next state equation? Okay, so this is your state diagram. You can notice there are two possible state, 0, 1. Okay, and now I want to write the next state equation. Okay, so from this state diagram, very simple. The point is just focus on when the state is becoming 1. Okay, just focus on this one, when your state is becoming 1. So remember, from a state diagram, if you have a state diagram, from the state diagram, if you want to write the equation of the next state, because remember this is the state, this is the state, so either the state can be 0 or the state can be 1. Okay, now I want to write the equation for next state. Okay, so the state can be either 0, the next state can be either 0 or the next state can be 1. Okay, and you know that your next state, that will depend on your current state. What is your current state? Okay, and what is your current inputs. So okay, now you can notice, let me tell you that when you write the equation for the next state, then just focus on when it will become 1. Just focus on it when it will become 1. So tell me, when the next state will become 1, only focus on that. Why? What is the reason? The reason is this, because you can notice that if you focus on 0, then that will become 0. For example, this term s bar r, this s bar r 0, so that will become 0. So you don't have to worry about the 0, you only have to focus on 1. Okay, so you can notice what will the next state. The next state will be very simple. Okay, so when you are getting 1, when the next state is becoming 1, just focus on that. So I can say that if your current state is 0, means when your current state is 0, means q bar, I can say. Okay, when current state is 0, when your current state is 0, means q bar. Okay, so q bar. Okay, then in that case this s r bar, this is s r bar. So I can say, okay, or, so remember what I'm doing. Okay, remember, focus here what I'm doing. I am saying that when, just focus on when this next state will become 1. So if you want the next state to become 1, if you want next state to become 1, then there are two possibilities. What are the two possibilities? Either you are in this state or you are in this state. Now if you are in this state, means your current state is 0, so I can say q bar, because q is 0, so it means I can say q bar. In this state, if you apply s equal to 1, r equal to 0, in this state q bar, in this state if you apply s equal to 1 r equal to 0, then you will go to this state. Or what you can say, I can say that if you are in this state already, if you are in this state already means, okay, if already you are in this state, okay, you are in state q equal to 1, then you can notice either you can apply s bar r bar, okay, either you can apply 0 0, or you can apply, okay, s r bar, okay, either you can apply s bar r bar or you can apply s r bar. Now you can just simplify this equation. So okay, this is the equation we got. You can notice qn, okay, so this equation we got q s r bar cube, okay, and then you can notice, okay, q s bar r bar, and that is q s r bar, okay. So this is the point. Now you can notice from here, okay, so I can take this one and that will become s r bar, and this will become q s bar r bar, okay. So this is what we got from the state table also, and this is your next state equation. Remember, I am not saying that this is minimized, okay, this is not minimized, because if you want to get the minimized equation, then you can create a k-map, okay. So for the sr flip-flop, you can notice in this sr flip-flop, actually this combination, if you notice s equal to 1 r equal to 1, this combination is forbidden. Because this combination is forbidden, so what I can say, I can say that because this combination is forbidden, so this combination is actually don't care combination, okay, because this combination we will never apply. The input can never be s equal to 1 r equal to 1, so this is actually a don't care combination. And you can notice when you have don't care combination, then the best method is k-map, okay. So just create a k-map and you can get the equation, okay. So from the k-map you can basically, you can very easily get the equation, okay. So like this you can create the k-map s, okay, s r q, like this, okay, you can create a k-map and you can get the equation for qn, okay. So I am not saying that this is the minimized equation, okay, this is what, but this is a correct equation, okay. If in the options this is given to you, if this is in the options, then this is correct, okay, because this is correct, but this is not minimized, okay, because using this don't care combination, this don't care combination, either you can take it as 1 or you can take it as 0, okay. So depending on that, you can minimize this, you can get a minimized equation, okay. But my purpose is not to tell you what is the minimized equation, that we have already seen in the flip flop when we have studied this sr jk t d, okay, all these flip flop when we studied, at that time we have already seen how to write the minimized equation and all these things, okay. Okay, now let's see for jk flip flop, okay. So you know what is a jk flip flop, okay. So this is the state table of the jk flip flop. In the jk flip flop, when the input is 0 0, when you apply this input, then the next state will be unchanged, so I can say the next state will be same as the present state. In jk flip flop, when you apply these inputs, then the after one clock cycle, what will happen, when you apply these inputs, then after one clock cycle, I can say the next state, that will be basically reset, okay. Similarly, if you apply this combination, means j equal to 1 k equal to 0, then in this situation the next state will be 1. And if you apply this input combination j equal to 1 k equal to 1, then the next state will be complement of the present state, so I can say the next state will be q bar, okay. So this is your state table, okay. So you can very easily see this is the state table. Now from this state, this is the state table. Now this state, we can also create state diagram. So what is the state diagram? In the jk flip flop, okay, only two states are possible, this state and this state, only these two states are possible, because you know that every flip flop is a one bit storage device. So every flip flop has only two possible state, okay. A flip flop can be either in state 0 or it can be in state 1, okay. So these are the two possible state. Now what is state diagram, okay. So if I talk about what is the state diagram, then state diagram means how do we go from one state to another. For example, if you want to go from state 0 to 0, or you want to go from state 0 to 1, or you want to go from 1 to 1, or you want to go from 1 to 0, okay. So what we should do, now let us assume you are in state 0. Now from state 0, if the next state also should be 1, means from this state again you want to go to 1 after one clock cycle. So this is your present state, you are in this state. After one clock cycle again you want to go to this state, then what you should do, very simple, either you apply the input j equal to 0 k equal to 0, or you reset it. Reset means j equal to 0 and k equal to 1, okay. Similarly, you can notice that if I want to go from this state to this state, you are in this state, this is your present state, 0 is the present state, you want to go in this state 1, okay. Then what you can do, either you can set, okay. So either you can set means j equal to 1 k equal to 0, or you can toggle means, okay, so basically complement. So if you apply this input combination j equal to 1 k equal to 1, then you can notice the next state will be basically complement of the present state. This is your present state, so the complement of this state will be state 1. Okay, similarly if you are in this state 1, then again the next state also should be 1. Then what you can do, either you can apply the input combination 0 equal to 1, j equal to 0, k equal to 0, or you can set, okay, or you can apply 1 0. Similarly if you want to go from state 1 to state 0, then what you can do, either you can reset, or you can apply the toggle. This is the state diagram of JK flip-flop. Okay. Now from the state diagram, you can very easily write the state is in next state equation. Okay. So let's write the next state equation. And I told you when you write the next state equation, then the very simple method is just focus on when next state is becoming one. Okay. My target is to write the next state equation. This is what I want to write, next state equation. So it means that my focus will be when the next state will become one. Just focus on that, when the next state will become one. So you can notice here, okay, either you are in this state or you are in this state. Okay, if you are in this state, means if you are in state q equal to 0, means if you are in this state, then you can notice how will the next state will become 1. Okay, when you apply these combination, means I can say either you apply j equal to 1, k equal to 1, or what you do, or you apply j equal to 1, k equal to 0. Okay, so you can notice if you are in this state means q equal to 0. Okay, so if you are in this state, then either you can apply this input combination or you can apply this input combination to go to state 1. Okay, so this is what I am saying, when you write the next state equation, just focus on going to 1. Okay, so if you are in this state means q bar. Okay, in this state either you can apply j equal to 1, k equal to 1, so that is q bar jk, or you can apply j equal to 1, k equal to 0, so that is q bar jk bar. Okay, or what you can do, or maybe you are in this state. If you are in this state means q equal to 1, then either you can apply this combination, this is j bar k bar, or you can apply another combination, that is, okay, or you can apply this combination, this is, okay, I can say this is j k bar. Okay, so this is your next state equation. Remember, I am not telling you how to write the minimized equation. This is not a minimal. If you want to write the minimal equation, then you can use the k map. Okay, using the k map, remember, you can write the minimal express equation. So you can notice using the K-map, you can get a minimized next state equation. But what I want to do, I just wanted to tell you this method. Okay, this method I wanted to tell you. From the state diagram, you can very easily write the next state equation. When you write the next state equation, just focus on when the next state will become one. If you want the next state to become one, then very simple. Either you are in this state. If you are in this state, then you have to apply these input combination. If you are in this state, then you have to apply these input combination. Okay, then finally we will get this next state equation. Okay, this is not a minimized equation, but this is correct. This equation is correct. Okay, if you want to get minimized equation, then you can apply k-map. Okay, so this is the point. Now from the state table also you can get the equation. This is your state table, and from state table also you can get the equation for qn. You know what is this qn? The next state that will depend on the present state and what are the present inputs. In a sequential circuit this happens because in a sequential circuit the next state always depends on what is your present state. Okay, what is your present state and what are your input. Okay, what are your input, on these two things your next state will depend. So here very simply you can write the next state, that is very simple. Okay, when j is 0, k is 0, then the next state is q. So I can say when j bar k bar, then the output qn will be q. Similarly, okay, when j equal to 0, k equal to 1, then the next state will be 0. You don't have to write it because this will again become 0. Okay, actually this is your j bar k 0, and this actually it will become 0. So you can notice this actually will become 0. Okay, similarly when j equal to 1, k equal to 0, it means j k bar, then the next state will become 1. Okay, so the next state will become 1. And similarly when j equal to 1, k equal to 1, then next state will become q bar. This is how you can write the equation. Okay, so anyway, the point is very simple, that from the state table also you can write the next state equation, and from the state diagram also you can write the next state equation. If you want to get minimized equation, then you can use the k map. Okay, now let's see for t flip flop. Okay, so okay, let's see for d flip flop. Now again very simple, if you have a d flip flop, then let's first write the state table of this d flip flop. Okay, so what the state table of a d flip flop? This is your input d, only one input we have. Okay, and what the next output? So you can notice if you apply in a D flip flop, this is your data flip flop. Okay, remember why this is important? Because very simple. If you want to store some data, just apply it and it will be saved. Okay, so you can notice this is the benefit of D flip flop. This is a D flip flop, and if you, for example, if you want to apply, okay, let us assume this is your clock. Let us assume this D flip flop is a positive edge triggered. Now I am saying that if you want to store some data, for example, I want to store. Let us assume this is my data right now. Right now, this is my data, and I want to store one. I want to store one. Very simple. If I want to store one, then just apply one. Similarly, if I want to store zero, then simply just apply zero. So this is the benefit of D flip flop. So that is the reason this is data flip flop, or I can say this is data storage flip flop. Whatever data you want to store, just apply it. Okay, so that is the point. Okay, so now you can notice if you apply the okay, if you apply input 0, then you can notice this will be stored. So you can notice whatever is your present state, it will not depend on that. Whatever is your present state, if you apply this input, if you apply this input data, then it will be stored. So the next state will be 0. And similarly, if you apply this input, then it will be stored. Okay, so you can notice that whatever data you are applying, that data is getting stored. So this is your D flip flop state table, and from this state table, very simply you can write the equation. Okay, so what is the equation for Qn? Very simple, that the next state is basically same as D. Okay, so next state is basically same as the current input. Next state is same as present input. And how can I write the state diagram? Okay, so for this D flip flop, very simply you can make the state diagram. Either this D flip flop is in this state 0 or it is in state 1. Okay, now only one input we have. Remember, this is a D flip flop, so only one input we have. Okay, now let us see all these three if you want to do like this. Okay, so if you, okay, let us assume this your present state is 0. So present state means present output. So let us assume your present output of D flip flop is 0. Now if you want the next state also should be 0, then what you can do? Very simple, just apply 0. Okay, similarly, if you want the next state to be 1, if you are in this state 0 and you want next state should be 1, then very simple, just apply 1. Okay, this is the benefit of D flip flop. If you are in this state 1 and you want next state also should be 1, just apply it. If you are in this state 1, if you are in this state 1, you want next state should be 0, very simple, just apply it. Okay, in this state, if you apply 0, okay, then this 0 will be stored. So this is the benefit of whatever data you want to store. Okay, whatever data you want to store, just apply on the input. Okay, so this is the point. So this is the state diagram. Now from this state diagram, again you can very easily write the state equation Qn. Okay, how to write the state equation? Just focus on when the next state will become 1. Just focus on that. Okay, so if you want to write the equation for this variable, this is your variable, this is the next state. Okay, so this is the next state variable. For this variable you want to write the equation, then very simple, just focus on when it will become 1. Okay, so if you want to write the equation for Q1, just focus on when the next state will become 1. Very simple. Okay, either you are in this state or you are in this state. If you are in this state, means if your present state is 0, means Q bar. Okay, if your present state, remember Q means present state. I told you that Q means present state, and you know what is Qn? Qn means next state. So you can notice if your present state is 0, means if you are okay, your present state is Q bar, then how can you, okay, how can you make 1? Very simple, you have to apply this. So okay, so you have to apply D equal to 1. Okay, or if your present state is 1, if your present state is 1, then again you have to apply D equal to 1. Okay, so from this you can very easily see this will become D. So from the state diagram, this is your state diagram, and from this state diagram also you can write the next state equation. Okay, this is how you can write from the state diagram, this is how you can write, and from the state table also you can write. Okay, so this is how we got the D flip flop next state equation. This is the next state equation. Now similarly we can see for T flip flop. T flip flop means toggle flip flop. Okay, so this is your toggle, or I can say complement. Okay, so this is your toggle flip flop. This is used for toggling. Okay, this is used for complementation. And the, okay, you know the state table is very simple. Okay, if your T flip flop, if the value of T is 0, then there is no change. So I can say next state will be same as the present state. Okay, but if your t value is 1, then the next state basically that will be the complement of the present state. Okay, so you can notice this is important. This is important that if your toggle, if your input t, if the t input is 1, means if you apply this input 1, then the next state will be complement of the present state. Okay, so from here what you can do, you can write the next state equation. So the next state equation that will be when t is 0, then the output is q. Okay, so I can say when t is 0, then the output is q. Okay, similarly, when t is 1, then the output is q bar. When t is 1, then the output is q bar. Okay, so from you can very easily see this is your, okay, this is the next state equation from the state table. This is your state table. Okay, so from the state table you can write this, and we can also make the state diagram. You can notice whatever flip flop you take, that can either be in state 0 or it can be in state 1. Now you can notice, okay, this is your state diagram. So in the state diagram what will happen? Very simple. If you want to go from this state to this state, if you want to go from state 0 to state 0, then very simple, you have to apply t equal to 0. Okay, if you want to toggle, then you have to apply t equal to 1. If you want to go from this state to this state, then you have to apply t equal to 0. And if you want to toggle, okay, your present state is 1, let us assume your present state is 1, and you want next output to be 0, then very simple, you can apply t equal to 1. Okay, so this is the idea. This is your state diagram. Now from this state diagram, you can write the next state equation. This is the next state equation. Next state equation, how can you write? Very simple. I told you, whenever you write the next state equation from the state diagram, you have a state diagram. From this, you want to write the next state equation. Then there is one way, very simple way. What is that? Just focus on when the next state will become 1. Okay, when the next state will become 1. You can notice if your current state is 0, means q bar. If your current state is 0, then what you have to do? You have to apply t equal to 1. Okay, so if your current state is 0, then t should be 1. Okay, then input should be 1. If your current state is 0, if your current state is 0 means q bar, then input should be 1. And if your current state is this, if your current state is 1, then you have to apply t bar. Okay, then you have to apply input equal to 0. Okay, so again we got q exclusive or t. Okay, so this is how you can get the next state equation from the state diagram, the next state equation from the state table. All these things we have seen. Okay, so you can notice if you have one flip flop, then two states are possible, that is 0 or 1. Okay, so from one flip flop, only two states are possible, either 0 or 1. Okay, and you can notice each state has one bit. You can notice. Okay, so because either this state is possible or this state is possible. With the two flip flop, how many states are possible? With the two flip flop, either this state is possible or this state is possible or this state is possible or this state is possible. So four states are possible with the two flip flop. Okay, because you have two flip flop, so there are these many four state possible. Because what is a state? A state means flip flop output combination. So because you have two flip flop, so these are the flip flop output combination that are possible. Okay, and you can notice each state has two bits. Similarly, when you have three flip flop, then how many states are possible? Three flip flop, then state means flip flop output combination. So because you have three flip flop, so this is the output combination possible, this is the output combination possible, this is the output combination possible, this is possible, this is possible, this output combination is possible, this and this. So these total 8 states are possible, total 8 flip flop output combinations are possible. And you can notice each state has 3 bits. Okay, because you have three flip flop. Okay, three flip flop, so each state will have 3 bits. Okay, because you can notice each state is nothing but a flip-flop output combination. And so I can say each state, because you have three flip-flops, so each state has 3 bits. Similarly, when you have 4 flip-flops, then each state will have 4 bits. Okay, and total 16 states will be possible. Okay, now let's see this example. This is a circuit diagram that is given to you. First you tell me in this how many flip-flop we have. So you can notice only one flip-flop we have. So you can notice this circuit, this sequential circuit can either be in state 0 or it can be state 1. Because I told you, when you have one flip flop, then only two states are possible. Here you can notice only one flip flop we have, so only two states are possible. Either the state can be, state means this output A. I told you, state of flip flop, that means what is the output of a flip flop. Okay, so for this whole circuit, this output A is the state of this circuit. Okay, for this circuit, this is a sequential circuit. Why? Because we have flip flop. Sequential circuit is a circuit with a flip flop. Okay, so in this sequential circuit, the state of this sequential circuit, that is nothing but output of the output combination of flip flop, and there is only one flip flop. So this output of this flip flop is basically the state of this sequential circuit. Okay, now let's see, okay, what is the state diagram and what is the state table. So let's see that. From this you can very easily notice, from this table, from this diagram you can notice what is the input D. So you can notice what is the input D. Okay, so this input D, that is nothing but exclusive or of okay, this, that is XOR of x comma y. Okay, so that is XOR of x comma y. This is XOR of x, so this is XOR. Okay, this x XOR y. So very simple, you can notice here, this is x XOR y, and this is a here. So I can say this is finally x XOR y XOR a. Okay, so you can notice the input D, that is nothing but x XOR. Okay, so this is the input D. Now let's make the state table. So first I will show you how to make the state table. State table, very simple. Okay, because you can notice the next state, remember the next state will depend on the inputs and the present state. Okay, here the next state means an, I can say a next. Okay, so here I can say a next, because okay, so a next. Okay, here this is the next state. Okay, here this is the next state, and you cannot, that will depend on what is your present state. This is your present state. Okay, and what are the inputs? And the inputs are x comma y. These are the external inputs, x comma y. So okay, on x comma y. Now you can notice, so finally what is the table that we will get? Okay, so finally the table will be x y. Okay, and this is a next. So you can notice, if your x y are 0 0, if you apply this x y equal to 0 0, then remember this is a D flip flop. Okay, this is a D flip flop. So you can notice the next state, that will be basically same as present. Okay, so because this is a D flip flop, so I can say the next stage is actually same as the present input. Okay, this present value of D, the next state will be same as the present value of D. So this an will be same as D. Okay, so you can notice when you have x, so finally here you can notice an is equal to D. This we already know from the D flip flop, because this is a D flip flop. So the next state will be same as the present input. Okay, now I am saying that when x is equal to 0, y equal to 0, then what is the next state? Very simple. Just find out the value of D. Okay, when x is equal to 0, y equal to 0, so this is 0 exclusive or that 0, that is 0. 0 exclusive or A. Okay, what is that? So you can notice if A, okay, what is that? If A is 0, then it will be 0. If A is 1, then it will be 1. So this is actually simply A. So you can notice when x equal to 0, y equal to 0, then the next state will be A. When x equal to 0, y equal to 1, then what will be the next state? Okay, so similarly in this situation. Okay, so let's find out. Now tell me what is 1 exclusive or A. What is that? If A is 0, then the output will be 1. If A is 1, then the output will be 0. So basically this is A bar. Okay, now let's see. So when x is 0, y is 1. Okay, when x is 0, y is 1, then this will become 1. 1 exclusive over A, that will become A bar. Similarly, when x is 1, y is 0, then again you will get A bar. And when x is 1, y is 1, then what you will get? Then this will become 0, and then finally you will get A. Okay, so this is your state table. Very simple, quite very simply you can make the state table. So for these input combinations, you can notice the next. Okay, if you apply this input combination, x equal to 0, y equal to 0, then the next state will be same as the present state. If you apply this input combination, then the next state will be complement of the present state. If you apply this input combination, then the next state will be same as the present state. Okay, so this is your state table. From this state table, you can write the next state equation. Okay, so let me write the next state equation from this table. Okay, so let's see that. Okay, so what that will be? So very simple, this an. Okay, so from this table, very simple, that when x is equal to 0, y equal to 0, I can say x bar, y bar, then you will have A. Okay, and similarly when x is 0, x bar, y, then you have A bar. And when x is 1, okay, y is 0, then you have A bar. And similarly when x is 1, y is 1, then you have A. Okay, so this is your next state equation. Remember, this is correct, but this is not minimal. If you want minimal equation, then you can use K-map method. Okay, so let me use the K-map method. So if you want to get the minimized equation, then you can use the K-map method. You already know that an, the next state, that is a function of what is the present state and what are the inputs, x comma y. Okay, so this we already know. So very simple, what you can do, you can make a 3 variable K-map. Okay, so this is a 3 variable K-map you can make. Okay, here I can put xy, and here I can put A. Okay, so what I can say, here I can put A. Now very simple that. Okay, so this is okay, so you cannot, this is the area of x, this is the here, okay, y, and here you have A. Okay, so this you already know, this is your K-map. Okay, 0 0 0 1 1 1 1 0 and 0 1. Okay, so this is your K-map. Now let's fill the entries in this K-map. Let me fill the entries. Okay, so you can notice when x is 0, y is 0, then the next output, then the next output is same as the present output. So the next state is same as A. So when x is 0, y is 0. Okay, what is that area? So okay, when x is also 0 and y is also 0. So you can notice in this area, okay, here x is 0, y is 0. So here the next state, okay, remember this is a K-map for AN. Remember this is K-map for A next. Okay, so you can notice here when x is 0, y is 0, then what should I put? Then I should put an equal to a. Then an will be equal to a. Then the an will be same as a. You can notice here what is a, that is 0, and here a is 1. So let me just put 1 here. Okay, because in the K-map, okay, because I'm writing the SOP expression. If I want to write SOP expression, minimized SOP expression, then I will focus only on 1. I don't care about 0. Okay, so this 0 I don't care about it. Okay, so I will write 1. Very simple. Next, when x is 0, y is 1. Okay, so what is that area? So you can notice x is 0, y is 1, means this column. Okay, means this column. In this column you can notice a next will be a bar. A next, that will be a bar. So you can notice here we will have 1 0. Okay, so I don't have to write 0. Next, when xy is okay, x is 1, y is 0, this area x is 1, y is 0, then you can notice the next state an will be complement of present state, complement of a. So again here you will get 1 here. Okay, and similarly when x equal to 1, y equal to 1, then you will get an equal to a. Okay, so here I can write 1. Okay, so this is what you are going to get. And you can notice this is a okay, from here if you write the equation, then what you will get? Very simple. Okay, so these are the essential prime implicants. Okay, so you cannot this all the okay, only this is the grouping possible. So actually this expression you will get, you cannot simplify it further. Okay, so this is actually your minimized expression. Okay, so from here you can get the minimized expression, you can very easily write. Okay, and the same expression you will get here. Okay, so here what the an, and that will be same as this. Okay, so both are actually same. So I can say x bar y bar a. Okay, and similarly x bar y a bar, and similarly x y bar a bar, and x y a. Okay, so this is the minimized equation that you will get. Okay, so for this sequence circuit, you know that only one flip flop you have, so only two states are possible, either state 0 or state 1. So now let's write the state diagram. Okay, for this sequence circuit, now you can notice only one flip flop we have, so only two states are possible, that is state 0 and that is state 1. So I can say that okay, either this state is possible, I can say a equal to 0 is possible, either the present state is a equal to 0 or the present state is a equal to 1. Okay, so only these two states are possible. Now very simple. Okay, if you want to go from this state to this state, if you want to go from 0 to 0, then what you can do? You can apply, either you can apply 0 0 or you can apply 1 1. Okay, remember, either you can apply x equal to 0. Okay, so this is your x, this is your y. Either you can apply x equal to 0, y equal to 0, or you can apply x equal to 1, y equal to 1. If you want to, if you don't want to change the state. Similarly, if you don't want to change the state, you can apply 0 0 or you can apply 1 1. If you want to complement the state, then what you can do? Either you can apply 0 1 or you can apply 1 0. Either you can apply 0 1 or you can apply 1 0. This is the state diagram. This is how you can create the state diagram. Remember, in this sequence circuit, only one flip flop we have, so only two states are possible, either state equal to 0 or state equal to 1. State means basically a. Okay, because I told you state of a flip flop, that means the output of the flip flop. State of a sequencer circuit is basically the output combination of the flip flop. Only one flip flop we have, so I can say state of this sequencer circuit is basically output of this flip flop, and that is nothing but a. So you can notice only two states are possible, either a equal to 0 or a equal to 1. These are the two states possible, and the inputs are x comma y. So this is your x, this is your y. Very simple. If you are in this state and you don't want to change the state, then either you can apply x equal to 0, y equal to 0, or you can apply x equal to 1, y equal to 1. Okay, so this is the state diagram that you will get. Okay, now from this state diagram you can write the state equation, the next state equation. Okay, so let's write the next state equation from this state diagram. This we have already seen many times. Okay, so let me just write it here. Okay, so just focus on when, okay, I told you from the state diagram, I gave you a trick, very simple trick I gave you, that if you want to write the next state equation, then what you can do? Just focus on when the next state will become 1. If you want to write next state equation, you want to write, then very simple, what all you have to do, just focus on when the next state will become 1. Okay, so this is actually your next state. Okay, just focus on when it will become 1. Very simple. See, either your either you are in this state or you are in this state. Now very simple, if you are in this state, then to make the next state one, if you are in this state, this is your current state, then if you want to make the next state one, then either you have to apply this combination or you have to apply this combination. So I can say when your present state is 0, I can say when your present state 0 means a bar, then either you can apply this input or you can apply this input. Okay. Or if your present state is this, if your present state is a 1, means if your present state is 1, okay, if your present state is 1, then what you can do, then either you can apply this or you can apply this. So this is how you can get the, this is your next state equation. Okay, so from the state diagram you can very easily get the next state equation, and similarly from the state table also you can get. So either you can use state table or you can use state diagram or you can use K-map. Okay, you can use any of them to get the next state equation. Okay, so for this question we have done the complete analysis. We have seen how to write the state table, we have written the state this equation. Okay, so all these things we have seen. Okay, now let's take this example. Okay, so you can pause the video and you can try to solve this video. Basically for this sequence circuit, this sequence circuit is given to you. In this we have two flip-flop. Okay, and this is the circuit. Derive the state table and the state diagram of this circuit, and also what is the function of this circuit. Means basically in function of the circuit I can say next state equation. Okay, find next state equation. Okay, so this next state equation also you find next state equation also, what is that? Okay, so this is, you can pause the video and you can try this question. Okay, so now let me answer it. First of all, you can notice that okay, you have two t flip flop. This is a flip flop, this is a flip flop, so you have two flip flop, so four states are possible. First of all, let me tell you that there are four states possible. Okay, so you can notice here the four states are possible here. What are the four states? Because you have two flip flop, so four states are possible. And what are those? Okay, so the four states that are possible, that are either, okay, either this or this or this or this. So you can notice these four states are possible. Okay, so because you can notice for this T flip-flop the output is A, and for this flip-flop output is B. So I am saying that four states are possible. State means basically the flip-flop output combination. Okay, this is the flip-flop output, this is the flip-flop output. And when I say flip-flop output, then I want to say Q output, not Q bar. Remember, when I say flip-flop output, okay, when I say flip-flop output, then it means I am talking about the Q output. So you can notice this is the this is the output of this flip-flop, and this is the output of this flip-flop, and the output combination of flip-flop, that is the state of this sequencer circuit. So for this sequencer circuit, four states are possible: 0 0 0 1 1 0 1 1. These are the four states that are possible. Okay, now also let's write. So let me give it just number. Okay, t1, and let me call it t0. Okay, just let me call it like this, t1 t0, let me call it. Okay, now what is t1? Okay, so here you can write the equation for t1. You can notice what the t1 is OR. This is the OR. Okay, remember this is the OR. You can notice this is the OR. Okay, OR gate. So t1 is basically OR of, I can say, a OR of a, and OR of a comma b. Okay, so this t1 is actually a or b. And what is t0? What is this t0? Okay, so this t0 is actually, I can say, this is OR of a bar comma b. So this t0 is a bar or b, and t1 is a or b. Okay, very simple. Now first let me write the state table. Okay, so this is my first. Okay, let me write state table. Remember one thing that I told you, in a sequencer circuit, the next state here. Okay, state table I want to write, but remember here, because we have two flip-flop, so state of this sequencer circuit is basically a pair. Okay, remember here, because we have two flip-flops, so the state, you can notice this is a possible state, this is a possible state, this is a possible state, this is a possible state. So you can notice in this, because of t flip-flop, we, okay, every state will have two things. Every state will have two bits, I can say. Okay, so every state has two bits. Okay, so this is the point. Now you can notice in the state table what we can do. So the output, the state, the present state, so sorry, the next state, that will depend on what is your input. Okay, okay, and what is your present state. Okay, so let me write it here. So we already know that next state in any sequencer circuit, whatever sequencer circuit you take, then we know that next state in the sequencer circuit, that is basically function of, that depends on what is your present state and what are the external inputs. Now you can notice here in this circuit, okay, just focus on this circuit, on this sequence circuit. There are no external inputs. We don't have any external inputs. Okay, so you can notice in our circuit there is no external inputs. So what I can say, I can say that basically in this sequence circuit, the next state that is just a function of present state. Okay, next state is just a function of present state. And remember one more thing, because we have two flip flop. Okay, so you can notice because we have two flip flop, so the state of this sequence circuit, the state of this sequence circuit, okay, if you want to, okay, determine the state of this sequence circuit, then there will be two components. What are the two components? So state of this sequence circuit will have two bits. You can notice, because this sequence circuit, because we have two flip flop, so the state of this sequence circuit will have two bits. You can notice, okay, for example, like this, okay, so like this. So I can say, because we have two flip flop, so the state of this sequence circuit has two bits, that is a comma b. So what is the next state of this sequence circuit? That will be a next, b next. Okay, so this is the next state. This is the next state of this sequence circuit, and that is a function of present state of sequence circuit. This is the present state of sequence circuit. Remember, there is no external input here in this circuit. There is no external input. So that is the reason I can say that the next state is basically function of present state. Okay, so I can say a and bn. Okay, this is the next state of sequence circuit, that is function of present state of sequence circuit. This is the present state of the sequence circuit a comma b. Okay, so from here I can write the state table. Okay, so very simple, very simply I can write the state table, and that is, okay, so you can notice the next state. The next state means that is a and bn. Okay, so this is the next state. That will actually depend on what is your present state. That will depend on what is the present state. Okay, so what the present state either can be 0 0, or it can be 0 1, or it can be 1 0, or it can be 1. Okay, and you already know that this t1 is a or b. Okay, so you already know this t1, this is a or b. And you also know that this t0, okay, this t0, this is a bar or b. And you know that, okay, for this t1, the output q is a. And you also know that for this t0, the output q is b. Okay, so now you notice, okay, when a comma b are 0 0, okay, means if when your current state, present state is this, a is 0, b is 0, then you can notice that t1 is what? T1 is a 0. Okay, so here I can write like this. Okay, I can write the value of t1 also, I can write the value of t0 also. So okay, so you can notice when a is 0, b is 0, then the t1 will become 0. Okay, so you can notice t1 actually will become 0, and similarly here t1 will become 1 1, and similarly here t0 actually will become 1. Okay, and here t0 will become 1, here t0 will become 0, and here t0 will become 1. Okay, now you can notice this is our target. Okay, because remember the next state, this is the next state of sequence circuit, and this is a function of present state of the sequence circuit. This is the present state. Remember, this is the present state of sequence circuit, and we want to find the next state of the sequence circuit. Okay, and we are using t flip flop, so we have t flip flop. So you can notice from this we can find the value of t1 t0. Okay, now you can notice, you already know what the behavior of t flip flop. In the t flip flop, what happens in the t flip flop? You already know that when this t value is 0, then the next state will be same as the present state, and when t value is 1, then the next state will be complement of the present state. Okay, so you can notice that when t value, when this t1 is 0, because remember this t1 is actually associated with this a, because the output of this t1, that is a, and similarly output of t0 is b. Okay, so the output of t0, that is b. Okay, so I can say that what, okay, if your t1 is 0, then the next state, okay, that will be same as the present state. So you can notice, okay, so here the present state is 0, so that will be same. And here t1 is equal to 1. Here you can notice t1 is equal to 1. So in this situation I can say next state will be complement of the present state. So this next state, okay, this will be complement of the present state, so that will be 1 0 0. Similarly here also, here you can notice in these situations t0 is 1. So in these situations I can say then the next state will be complement of the present state. So I can say, okay, that you, this will be, okay, 1 0, and this will be 0. And okay, in this situation the next state will be same as the present state, so this will be 0. Okay, so bn will be b. Okay, so this is how you can find. Now, okay, this is your state table, and from this state table you can make the state diagram very easily, because there is no external input. Okay, so let's write the state diagram. Okay, so you already got the state table. Now let me write the state diagram. Okay, so this is your state table. You can notice in this state table, you can notice if this is your present state, then the next state will be 0 1. Okay, so if your present state is 0 0, if this is your present state, okay, so I can write like this. If your present state means AB, if your present state is 0 0, then your next state will be what? Then your next state will be, okay, that will be 0 1. Okay, so you can notice if your present state is 0 0, then the next state will be 0 1. Similarly, if your present state is 0 1, then the next state will be 1 0. If your present state is this, then the next state will be what? Then the next state will be 1 0. And similarly, if your present state is 1 0, then the next state will be 0 0. Okay, if your present state is 1 0 or 1 1, if your present state is 1 0 or 1 1, then the next state will be 0 0. So if your present state is, okay, this, then the next state will be this. Similarly, if your present state is 1 1, if this is your present state, then also the next state will be, okay, this is the state diagram. Okay, very easily you can see this is the state diagram of this okay, for this sequential circuit. This is the state diagram. This is how we are going from one state to another. You can notice in the state table, you can very easily notice, because we don't have any external input. So I can say the next state, this is the next state. This will depend on the present state of sequential circuit. This is the present state of the sequential circuit. If the sequential circuit has present state 0 0, then after one clock pulse, I can say after one rising edge, the next state will be this. If this is your present state, then the next state will be this. If your present state is this, then the next state will be basically this, like this. Okay, so finally you will get this state diagram. Okay, now once you have this state diagram, once you have this state table, you can write the equation for, okay, next state equation you can write. Okay, now basically, okay, so now let me write next state equation. Next state equation, remember, next state equation means I want to write an comma bn. Okay, because that is a function of a comma b, because we don't have any external input. So you know that this is the next state of sequential circuit. Okay, and this is nothing but, okay, so this is the next state, you already know. This is the next state of the given sequential circuit, of the given sequential circuit. Okay, and okay, you also know that this is the present state. This is the present state of the given sequencer circuit. Okay, and this is what I want to write. I want to write the next state equation. Okay, so let me write this an in so basically this an I have to write in terms of a comma b. Also this bn I have to write in terms of a comma b. So this an I have to write, and this bn I have to write, this an comma b1, these I have to write in terms of a comma b. So this is what I need to do. Okay, now from the state diagram also you can write. Okay, let me tell you from the state diagram, then we will see from the state table. Okay, from the state diagram, how can you write what is the equation for an? Okay, so let's see. Okay, I told you from the state diagram, I told you one very good, very easy trick. I told you that if you want to write the equation for the next state, then just focus on when the next state will become 1. Okay, so if you want to focus, okay, basically when this an will become 1. Okay, just focus on when this an will become 1, when the next state will become 1. Okay, when the next state will become 1. So okay, so when this an can be 1, this an can be 1 either here or this can be here. Okay, so you can notice this an. Okay, so what I'm saying that just focus on this an. When this an will become 1, when the next state, remember this is next state, I am writing the equation for next state. So when the next state will become 1. Okay, so you can notice the here you have, okay, here you have. Now when the next state will become 1, very simple. See, if you want this next state to be 1, then what are the possible ways? The possible ways are this. If you are here, if you are in this state, if you are in this state, then okay, then the next state will be an equal to 1. If you are in this state, then the next state will be an equal to 1. Okay, so you can notice if you are in this state means when a is 0, b is 1. What I'm saying, remember, very simple. When you are in this state, then the next state will be an equal to 1. Okay, just focus on when the next state will be 1, when means when this a next will be 1. Okay, so I can say that if you are in this state, then the next state will definitely be an equal to 1. So I can say when you are in a bar b. Okay, okay, is there anything else? Is there anything else? Or okay, okay, so you can notice this. Now you can notice here, okay, there is no, like, next state can never be 1. See, next state can never be 1, okay, because you can notice if you are in this state, then the next state will be an equal to 0. Okay, so this is your answer. Okay, this is your answer. So this is how you can write the equation for an from the state diagram. Now let me write the equation for bn from this state diagram. Okay, just focus on when the next state will become 1, when this next b will become 1, next b will become 1. So you can notice next b can become 1 here, or next b can become 1 here. Okay, now next b can become 1. What it means? It means if you are in this state, then the next b will become 1. Remember, if you are in this state, then the next b will become 1. So I can say that next, okay, so if you are in this state, a is 0, b is 0, then this next b will become 1. Okay, and remember, okay, here next b can never be 1. Okay, here you can notice, like here we don't have anything like this. Okay, so because if you are in this state, then the next state actually will be b equal to 0. Okay, so this is your equation for bn. Okay, so from state diagram, this is how you can write the state equation, next state equation from the state diagram. Okay, if you understood this, very easy. Okay, if you understood, okay, then very good. Okay, but if you did not understand from state diagram how to write the new next state equation, if you did not understand, then you can use the state table. Okay, remember, you can use the state table, very simple. Okay, there is no problem. Okay, just use the state table here. So let me use the state table. Okay, so now let me write the next state equation from this state table. Okay, let me repeat again. If you understood from state diagram how to directly write the next state equation, if you understood, then very easy. Okay, but if you did not understand, then there is no problem, you can use the state table. Okay, now let me use the state table. Now I want to write an. Okay, so what that will be? Very simple. An is 1. Okay, because here we have 0 0. Okay, so an is 1 in this situation. Okay, here we have an equal to 1. Okay, so just focus here. So here an is equal to 1, so I can say an will be basically nothing but a bar b. And similarly, what when this bn is 1, okay, this bn is 1 in this situation. Okay, so you can notice in this situation bn is 1, so I can say b next will be a bar b bar. And okay, so you can notice from the state table very easily you can get a next state equation. So from the state table also you can find this next state equation. Okay, so I can say that an bn, okay, and this is a function of a comma b. Okay, so I can say the next state a and bn, that actually will be okay, a bar b, okay, comma a bar b bar. So next state will be a bar b comma a bar b bar. Okay, so this is how you can do. Okay, so I hope all these points are clear to everyone. Okay, I have told you what is how to create a state table, how to create a state diagram, how to create next state equation from the state table, from the state diagram. Okay, so all these things we have seen. Now in the next lecture we will start the discussion on finite state machine. Okay, so the next topic will be finite state machine. Okay, and we have two type of finite state machine we will study. There are many type of finite state machine, but two type of finite state machine. Okay, this is our topic for the next class. Okay, finite state machine. Okay, and two type of finite state machine we will study. One is Milli machine and another is Moore machine. Okay, so these two finite state machine we need to study. Okay.